Hey there, I'm Tyler Coyle, and I'm here to go over a quick guide on how to level up your print function skill on Python 3. Now, you might be thinking, well, it's print, what more can you do? You might be surprised on what all print offers out of the box. Now, it does just work to print items out on your screen in a terminal, but there's a little bit more you can do with it, so let's go over that reference material now. If you like my content, make sure you like and subscribe below. And feel free to leave a comment in the comment section on any future guides or references you'd like to see. So without further ado, let's get into my text editor. So in my VS Code, I've got a series of files that I'm going to use to illustrate my points as we go through the Python documentation. So let's load it up real quick. In the Python docs, we can see the print function takes a number of arguments. It can take any unnamed arguments and will be packed into objects. We can set a separator, we can set an end, a file, and set the Boolean flush. So quickly skimming through the documentation, it says it will print objects to the text stream file, separated by the separator, and followed by an end. Sep, end, file, and flush, if present, must be given as keyword arguments. So that basically means you need to specify sep equals, end equals, file equals, flush equals. All non-keyword arguments are going to be converted to strings like string does, and written to the stream separated by sep and followed by end. Both sep and end must be strings. They can also be none, which means to use the default values. If no objects are given, print will just write the end. The file argument must be an object with a write method, and if not present or none, standard out will be used. Since printed arguments are converted to text strings, print cannot be used with the binary mode file objects. For these, use the file.write instead. Whether output is buffered is usually determined by file, but if the flush keyword argument is true, the stream is forcibly flushed. So let's go into this a little bit. First, we'll start with the object's input. So we have a simple hello world, and we'll just see what that looks like. Oh, let's type in the terminal, Python 1 basic usage, and we'll see hello world. Easy. This is something that everybody starts with. Hooray, you've hit beginner status on Python. But let's level up a little bit more. If we take hello world and put a comma between the words, we'll actually take that star notation and it will put a space separator, so the space separator, between each of the objects that it finds, hello world. So there we go, we've got our basic usage for the print function. But let's level up a little bit. Let's talk a little bit more about the separators and ends. So let's hop over to the second file. And I've got a series of lines already written out. And we'll first go with just that basic hello world with the separator defined. And you'll see this just prints out hello world without any use of this dash. That dash only comes into play whenever you provide a series of unnamed arguments into the print function. So for example, this is this, comma, is, comma, a, comma, longer, comma, phrase. And then we're going to use the separator of dash. So we'll still print out the hello world, all as one singular input. And then we'll also print out a second line that has 5 inputs. And we'll see that that dash separator gets put in between each string automatically. So you might see this could be a good replacement for somebody doing join and this is a longer phrase. Oh, I need to print that. So you can see these outputs are the exact same. One way you can accomplish this if you have a list is you can do the same unpacking that the print function does into it. So if we say print this list with a separator of dash, let's comment out all of these, we'll see that we'll actually get printed out these brackets in this print function. So let's see that. See, it's still in a list because we're actually showing the text representation of the list. But here's a fun fact, that same star notation that will take any unnamed arguments and pack them into an iterable will also unpack them for you. So if I put that star in front of this list, now I've got the same exact output as this join with far less typing. So if you wanted a fun fact, there you go, that's a quick snip. Now let's talk about the end argument. Here I've got, this is a longer phrase and then basic string at the end to illustrate a point. Between each word, or after each print, we want to end it with a comma. Now you'll note the default is a new line, so we're replacing that new line with a comma. So if this were to be, let's show you the basic example. This print is a longer line. Three lines is good enough. We'll take this, comment this out, and we'll see what this looks like. This is a longer line, and you'll see that each line is on a new line, or each print statement is on a new line. But if we change it to be commas, we'll now see that it is a comma separated string. At the end, we'll include a new line, and then we'll go back to basic string. Now here, I could as simply as just remove that and get the same result. So there you go. That's some extra little knowledge for you on the print function, on how to use the separator and the end keywords, as well as a little snippet on using variable unpacking. But let's get into flushing. So here I've got a simple for loop, for I in range of 1,000,000, print line whatever number it is. So if I hit this right now, we'll do 3 flushing, we're going to see a bunch of lines print out. Now I'm running on a Linux system, meaning the printing to this terminal actually does consume some time. So I can cheat and have just the Python interpretation time from this for loop detected without having any of the print to terminal affecting my speeds. So for example, if I were to time this, and it's going to take a long time, I'm going to Control C out of it, and it'll tell me, hey, that took a second 0.8 to get through that, and it didn't even finish because I killed it. But if I send everything to dev null, that means, hey, don't print anything to my terminal, only go straight to dev null. This is kind of a little cheat to not have the delay in actually printing to your output buffer, but still have Python run through the code as fast as it can. So if I time this, this is going to take about a second of user time, about 0.4 seconds of system time. So let's talk about flushing. What flushing is intended to do is to say, hey, I want to manually force this output to be flushed rather than buffering it. Buffering is a system kind of built into Python to say, hey, let me capture a little bit of this in memory and then I'll do a bunch at one time, because flushing each time is a slow operation. But if I say, hey, let's build this up and then I'll flush at one go, you can save a little bit of time. So we can see the default in the documentation is to not flush after every line, and Python using sys standard out will determine when it should flush. But with this counting to 1,000,000, if we flush 1,000,000 times, we're going to see the output of this take a lot longer. And still running. and still running, and still running. And there we go. It took 4.6 seconds of user time and 3.12 seconds of system time. So this just kind of goes to show that this takes a lot longer to flush. I can't think of a great way to show the example of when you might want to use this versus not, but just be aware that if you come into a situation where you are needing to flush, this can improve, or this can affect your results in terms of speed. If I can think of a good example of how to demonstrate when or why you might want to flush more frequently, I'll probably redo this video or create a secondary video explaining that. But for now, I feel like if you are learning the print function, know that this is a slower operation because you're telling Python, hey, flush after this line every single time, rather than, hey, use your smart method and only flush when you need to. So next, let's get into the file parameter, which is sys standard out by default. Standard out, you might have seen me do this, greater than dev null. That says send everything from standard out to dev null. If I were to do 2 to dev null, that means send everything from standard error to dev null. I'm not going to go into much more detail than that. If you want to see more of that Unixy type stuff, just look up string redirection, I believe is what it is, or IO redirection, and you'll find lots of material. But let's go over the file write itself. So in the documentation, it says file argument must be an object with a write method. And opening files by default does have this write method. There's other methods as well. I think IO reader, or writer rather, has that as well. But this standard, or this basic method, will suffice. So we're saying, hey, open testout.txt and open it in write mode, but create it if it doesn't exist, and open this handler as the variable f. So now when I run this, we're going to print whoa there Nelly to the output of the f file. So I'm going to save this and run python 4 file write. And there we go. We saw testout.txt be created. Now if I run this again, it's going to overwrite the entire file. So I could change this to append, and then now we'll see it actually append to it each time. So if you're looking at logging or create a logging interface using print, you may want to be aware that overwriting a file versus appending to a file is important to notate. Personally, I don't use this method often. If I'm thinking about writing to a file, I usually use the logging library built into Python, but that's for another day. So let's do our final level up, and here's where I think a lot of people are going to see something interesting about the print function. So before we saw that there was a list of strings, and it actually printed out the text representation of that list. So let's see that in action. There it goes. It looks like a list. So the same thing can happen with a tuple or a set or a dictionary. So here is a set. A set looks a lot like a dictionary, but it's completely comma separated. There's no colon. The colon dictates key and then value. This just means item, item, item. And a set basically means guarantee unique entries into this list. There's more nuance to it than that, but if you're not familiar with sets, it's a unique list, meaning the same entry can't exist twice. So with these 4 entries, we got list, set, tuple, and dictionary. Let's print them out and see what they look like. We have a list, a set, a tuple, and a dictionary. Looks almost exactly like how we printed it, but that's because there's an actual double under method called string in the dictionary, tuple, set, and list methods, or in their objects. So if we make something ourselves, I can kind of show you some visual representation of what that looks like. So let's comment this out. I'll take this up. And in Python, there's this concept of magic methods or dunder methods. Repr is one of them, which means representation, I believe. And then another one is string. By default, you'll usually see repr represented this way with brackets, and it's kind of to say, hey, I've got this object, and here's a text representation of kind of what it looks like. So some people will put details in it, like if this was, I recently worked on a Discord bot, if this was a user, I could have user name equals their name, we'll do their name, and we'll say channel equals their channel, and it very well might look like that. Just give me a good representation of what the data structure looks like, but it won't be consumable in a text format. By that I mean it's not intended for it to be human readable, it's intended for it to be a representation of the data structure itself. So if we go back to what my set was, the double under string magic method is intended to be that human readable interface. So if you call print on these functions, it's going to print out the repr or the string. So let's see that, and I'll comment this out and then I'll explain what that one is in just a moment. Whoops. Nope. I didn't save. That's why. Okay, so we have random repr underscore repr represented in the first one, and random string output represented in the second one. So we called and instantiated random repr and instantiated random string, and we just printed out those instantiated objects. So whatever is present in these fields just gets printed out and converted to text. But what happens if you have both? What if you have both repr and string defined? Which one takes priority? Let's see that. So if we instantiate random both and print it out, we're going to get random both string output. When it comes to the print function itself, it is trying to look for the string representation of whatever object you're looking at first and fall back to the repr if that's not defined. So if you're making a large library for something, if you can expect that your consumers will use print on this function, be cognizant of whether or not you're going to use repr or string and what that data is meant to represent as you're making your code. But that's it for this video. That's the basics as well as a few level up concepts about the print function. I'll keep making videos and hopefully help you level up in other functions of the Python standard library. I'll see you next time.